Lesson 13.5, Probability Models. We're going to save this example for an in-class discussion. The standards we're looking at today are interpreting two-way frequency tables and looking at conditional probability. Here's the first slide we're going to start at. It says, the table below shows the amount of sleep for workers on a night shift and on a day shift. So here are those two shifts, and then here's a column for our total. We're going to categorize these into people that sleep less than 8 hours or sleep 8 hours or more. So we're going to pull a total of 100 people. So we want to find the probability that a person sleeps less than 8 hours, so less than 8 hours would be in this column, and they work the night shift. So the night shift is going to be in this column. So the and would be 12 out of 100. Which is 0.12 or 12%. Number 2, what is the probability that a person sleeps 8 or more hours, so that's this column, and works on the day shift. So then we're looking at 16 out of 100 people. For 0.16 or 16%. The last question says, what's the probability that a person sleeps 8 or more hours and works the night shift? So then we're looking at the 58 out of 100. So that gives us 58% of the employees. This is an example of a two-way frequency chart. This is going to help us simplify our probabilities. So our key concept is conditional probability is the probability that an event will occur given that another event has already occurred. And it is written as B, the probability of B given A. So this symbol right here means given. And it is read as the probability of B given event A already occurred. So examples of this would be, what is the likelihood you will pass your next test? Which means you passed the first one, and now you have to pass the second one. Will your chance be better if you study more? This is conditional probability because it is affected by studying. So if you study more, will you pass your next test? The table below shows the number of students who passed and failed the last math test and the amount of time they studied. What is the probability a randomly chosen person failed given he studied 4 or more hours? So it says given they studied 4 or more hours. So we want to look at all of the kids who studied 4 or more hours. So this is where our focus is going to be. So out of all of those kids, how many people failed? 2. So this is going to be 2 out of 36. So it's almost like this part in the pink that I highlighted helps us find our denominator. So out of the people that studied 4 or more hours, which would be 36, how many failed? And this reduces to 1/18, or about 6%. Here's another table. The table shows the number of cars and trucks that are red or blue at a local dealership. The first example says, what is the probability that we select a red what is the probability that we select a red vehicle given that it is a truck? So remember, this tells us what we're picking out of. So out of all the trucks, so out of all those trucks, so out of 10, what is the probability that we get a red one? 4 out of 10, which is 40%. Number 2 says, what is the probability of selecting a blue vehicle given that it is a truck? So again, we're in the pink section. Now we want to find the probability that we get a blue one. So now we're looking at the 6 out of 10. So that gives us 60%. And notice these two events, out of all the trucks, Getting a red and getting a blue are complements of each other because we only have choices red and blue. Number 3, what is the probability that a randomly chosen vehicle is a car given that it is blue? So this would look like, what is the probability that it is a car given that it is blue? So that means out of all the blues, this is our denominator. So out of the blues, how many are cars? So I think our numerator is going to be 10. What's my denominator going to be? Yes, 16. And that works out to be 62.5%. So this is conditional probability. Here's another table. A company has 150 sales representatives. 2 months after a sales seminar, the company's vice president made the table based on sales results. What is the probability that someone who attended the seminar had an increase in sales? So we're going to analyze what that sentence says. What is the probability that someone who attended the seminar had an increase in sales? So given they attended the seminar, who had an increase in sales? So I think this is what we're looking at. So given they attended the seminar, how many had an increase in sales? So out of all of those who attended, which would be this column, we want to know how many had increased sales. So our numerator is 0.48, and our denominator would be 80% of the staff. So if I reduce this, this gives me 60%, which tells us the more training a person has in this company, the more sales they're going to have, which would make the company CEOs feel that training is important for their employees. Here's our next example. 2 cards are selected in a sequence from a standard deck. Find the probability that the second card is a queen, given that the first card is a king. Assume that the king is not replaced. So that word that's hidden right there is not. So here's what we're looking at. We want what is the probability out of all the kings, if we get a king on the first draw, that we will get a queen on the second draw. So some people like to write it out like this. Here's what we want on our first try, here's what we want on our second try. If we get a king on the first draw, what is the probability that we get a queen on the second draw? And assume that the king is not replaced. So here's a look at what our deck of cards would look like. Remember, a deck of cards has a total of 52. So we have diamonds, clubs, spades, and hearts. So what is the probability of us drawing a king? There are 4 kings in the deck. A king of diamonds, a king of clubs, a king of spades, and a king of hearts. So there are 4 out of 52 ways for us to get a king. Then we are going to keep that king out. So now our deck of cards only has 51 in it. So given that we drew a king on the first draw, what is the probability that we're going to draw a queen? So highlighted in pink, these are my queens. Again, we have 4 out of our deck. So now we have 4 out of 51 are queens. So then we need to multiply this, which reduces to 4 out of 663. And as a decimal, this is approximately 0.6%, which is 0.006 as a decimal. So we have a very low chance of that happening. Example 2. The table shows the results of a study in which researchers examined a child's IQ and the presence of a specific gene in the child. Find the probability that a child has a high IQ given that the child has the gene? So first, let's figure out what we're trying to answer, which is this. Given they have the gene, what is the probability the child has a high IQ? So given they have the gene, so we are focusing in on this column, all the people who have the gene. So out of 72, how many people have a high IQ? 33. So again, this part tells us what our denominator is going to be, and the first part tells us what the numerator is going to be. So it's almost like this is a fraction, and this piece here is a fraction bar. And that works out to be approximately 46%. Here's the exit ticket. Please pause the video while you work on it. Here are the solutions. What is the probability that the person is a Democrat and they support the issue? So Democrat and they support the issue would be 24 out of our total 120. Which is 1/5 or 20%. Number 2, what is the probability that they are a Democrat given they support the issue? So out of all those that support the issue, what is the probability that they are a Democrat? And this gives us about 47%. Number 3, a student calculated the relative frequency of those who did not support the issue, given that they are Republicans, as 33 out of a total of 33 plus 36, what is the error in them doing this problem? So it looks like their numerator is Republicans who do not support the issue, and then to get our denominator, they did 36 plus 33, and they used this 69. So let's read the question again. A student calculated the relative frequency of those who do not support the issue, given that they are Republicans. So let's look at notation. So here's what we're looking at. What is the probability that they support the issue? They do not support the issue, given that they are Republicans. I believe that that is telling us the denominator has got to be out of all the Republicans. So I think we need to start with a denominator of 60, and then who does not support the issue, that would be 33. So I believe their numerator is correct, but their denominator is not. They chose out of all of those who do not support the issue when they should have done out of all the Republicans. This concludes our lesson.